Hey nerds, today we're checking out slope. So grab your notebooks and at the top, jot that in your notes. Slope is also called gradient by the British. So I will use the word slope, but perhaps you use gradient. Doesn't matter to me. Be ambidextrous. What I'd like you to think about as sort of a warm up to this idea is if you were hiking along these paths, which one would be the steepest? Which is the lowest difficulty, which is the highest difficulty to walk, which is impossible to walk, and kick that idea around. I mean, we can get technical, but think about it just like walking with a backpack on. Pause me until you have thought about that a little bit. Go. Cool. All right. Well, if you were to say walk this path and with a backpack on. That path would be pretty much flat. It would be essentially the easiest to walk across, where something like this would get steeper and steeper, and ultimately you can't walk up it any no more. It becomes no longer a path. Like this is a very steep path, but this one is no longer a path. It's a cliff, right? So what we're looking at is this increase in angle, right? We go from 0 angle to a little bit of an angle to a bigger angle, and this one is a 90-degree angle. This one's no longer a path. This is a cliff. So this one really doesn't make sense to think of as a path. So this is the lowest difficulty to walk, right? And this is the highest difficulty to walk. And this doesn't make sense to talk about walking along it because it's no longer a path, it's a cliff, right? So this one is sort of out of the discussion, right? So this one you might say has like 0 difficulty, and this one, if it was at a 45-degree angle, maybe you'd say it has 50% difficulty, and maybe as you go up and up, gets more and more difficult. But this one you can't walk anymore, right? All right, that's the basics behind slope, but here's what I'd like you to do is put this in your notes. Slope. It's the gradient or slope of a line is the measure of its steepness. And we talk about slope in how much it goes up divided by how much it goes over. How much the vertical changes divided by the horizontal change. You can tell the difference because when you look out at the horizon, right, the horizon is flat, right? So as the sun's setting, the horizon is horizontal, right? Or that guy's horizontal. All right, so the vertical change over the horizontal change. So it's how much does it go up divided by how much does it go over. Another way to think about that is change, this little Greek symbol, this little triangle is called delta. Delta. That means the change in the y values over the change in the x values, and maybe that's a little too technical, but we'll get into it. So this slope, the vertical change here, if we're looking at the vertical change between these 2 points, well, it goes up 1 unit. So the slope, we call the slope m, the variable that's attached to slope is m, so we'd say that the slope for this thing is, well, 1 unit up and divided by horizontal change, 2 units over, 1, 2. So 2 units over. So the slope is a half. Great. And if we wanted to get to the next point, we would just follow this. 1 unit up, 1, 2 units over. That looks like it should be the next point. And if we make a line out of it, right, going from here, it looks like it hits that line, and it does. Great. Take that idea, try B and C. Pause me until you got it. Go. Cool. So same sort of thing on this. We're looking at how much up does it go divided by how much over does it go. So the slope for this is, oh, this only goes up 1 also. So its rise between here and here is 1. And its run is 1, 2, 3, 4, 5. So its slope is 1/5. If you looked at these, I know that this one is longer. I know that this one is a physical longer length than this. But if you look at the angle here, that angle and this angle, B has a lower angle. It's less steep. And you can tell that because this 1/5, if you changed it to a decimal, is 0.2. And this, if you change it to a decimal, is 0.5, right? That means that this has a lower slope. Cool. If we're looking at C, we can do the same thing. We're looking at the rise, how much does it go up versus how much does it go over. Well, it goes up 1, 2, and it goes over 1, 2, 3, 4. So this is 2, this is 4. So this slope is 2 over 4. It simplifies to a half, and because you can do this too, you can say, all right, well, that's one way to go from a point to point. This point is also on the line, so you could go up 1 and over 1, 2, and 1 and 2, and so it should also have a slope of 1/2, and it does, because if you simplify this fraction, it's 1/2, right? So slope is half here. Great. Sometimes you'll see this, instead of calling it vertical change, sometimes you'll see it as rise. How much does the line rise from one point to another? And instead of calling it horizontal change, sometimes you'll hear it as run. How much does it go over? So sometimes you can see slope as rise over run. Yeah, that's just a colloquial way to say it. Great. So slopes can be uphill and they can also be downhill, right? So a positive slope goes up as you look at it from left to right. So as your eye tracks it from here to here, you can see that as your eye moves across, reading left to right, it goes up, 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 up. So this thing has a positive slope. Cool. We go horizontally over, and we have to go up to get to the next point on the line. Here, this guy has a negative slope because as you read from left to right, it goes down. So we start here and we go over to the right as we read, and we have to look down to get to the next point. Cool, so positive and negative slope. So this might have a slope of, if this was 4 and this was 3, this would have a slope of rise 3, right, run 4. Right, so you'd say, okay, rise 3, run 4. So this is, I'm just making, there's no markations here. I'm just making those numbers up. If this was 4 and this was 3, we'd say that this would have a slope of, well, rise. Well, from this point to this point, it has to go down 3 units, right? So its rise is -3 over run. It's running in a positive direction, right? That way's well, this way's positive. So -3/4 is this slope. Cool? All right, we'll keep practicing that a little bit. So if you think about slope as like, negative slope is like if you were on a bicycle, you would just sort of coast downhill with that. So take that idea and try to find me the slopes of E, F, and G. Pause me until you get it. Go. All right. Let's get some purple going on. From this point to this point, it goes down 1, 2, 3 units, right? I'm going to put the negative because it's going down, and it goes over 2 units. So the slope for this line is rise -3, run 2, right? Slope for F is 1, 2, so slope is rise -2. It's going downhill from point A to point B. And then it runs 1, 2, 3, 4. We're not going to leave it like that because it's improper fraction, so we're going to leave it as 1/2. P.S. For fractions, -1 over 2 is the exact same as 1 over -2 is the exact same as -1 over 2. Right? Negative divided by a positive gives you a negative. Positive divided by a negative gives you a negative. And negative times a positive gives you a negative. These are all the same things. It doesn't matter to me how you write them. I usually like it like this because I know it either rises up or rises down depending on the sign there. Cool. Back to purple. This guy rises 1, 2, 3, 4. So rises -4 and run is 1. So slope is -4 over 1. And you can just leave that as -4. Cool? So who's the steepest? Well, this is -1.5. this is negative 0.5, and this is negative 4. So this is the steepest one, and this is the least steep one. And you can see that, I hope, here and here. If you were on a bike, this would be not too bad, and this would be fairly terrifying. Cool. All right, moving on. There's a little bit of a hiccup. If you were walking along here, this from point A to point B, it's, we're talking about slope as rise over run, right? How much does it rise from this point to this point? Well, it doesn't go up at all, right? It doesn't change its y, so it's 0 divided by some distance. I don't know, 1, 2, 3, 4, 5. I'm making stuff up, right? And 0 divided by 5 is okay, right? You can take 0 pizzas and divide them among your 5 friends, and everybody gets 0 pizza. Here, the slope is 0, and that makes me think of this as having 0 difficulty to traverse walking, right? So this slope is 0. The problem with that is that with this one, doesn't really make sense to walk on it. But if you look at the distance between, or the change between this point and this point, the slope is rise. Well, it does rise 1, 2, 3, 4, 5, 6. I'm making stuff up here. Let's call it 5. But how far does it go over from this point? Well, none, right? So its run is 0. If you crunch this in your calculator will look at you and say, undefined or error, or might just explode in your hands. So put safety goggles on before you do it. You can't divide it by 0, right? The idea is, I don't know if you've seen this before, but I can take nothing and put it in 5 groups. Every group has nothing in it. That's this idea. That's why this is 0. That's okay. But it's really hard to take 5 things and put them, this is essentially take 5 things and put them nowhere. Don't put them in any groups, right? And you can't, that doesn't physically make sense, right? So this has undefined slope. Undefined. It means it doesn't make sense to think about it. It doesn't have slope anymore. It's just a vertical line. This has 0 slope, and this has undefined slope. We'll work with that until it's comfortable. So here in H, well, see if you can figure out the slopes for H and J. Pause me until then. Go. All right, so this slope is vertical change, rise, over horizontal change, run. So rise is 1, 2, 3, and run is 0, right? 3 divided by 0 doesn't work. Here, I'll show you on my calculator. Can you see that? 0 divided by 3. This works. Where is it? 0 divided by 3. Oh, 0. If you switch it around, 3 divided by 0. If you divide it 3 by 0, you get this. Divide by 0, error, melt the world down. Dividing by 0 doesn't make sense. So this guy doesn't have no slope. It has undefined slope. Undefined. Cool. Conversely, this goes 1, 2, 3, 4, 5 over. So it rises 0. It doesn't go up at all from point A to point B, but it runs 5. And 0 divided by 5 is fine. That's 0. Cool? All right. 2 little interesting bits. This line B and this line A are parallel, right? You can tell because they never touch each other. And if you kept going this way forever and that way forever, they'd never run into each other. That's what parallel means. What I'd like you to do is pause me in a second and figure out the slope of B. Think about rise over run. And also figure out the slope of A. Think about rise over run. Simplify them and look at how they're connected. Go. All right, so for this guy, let's start here and work our way that way as we read. So I know that this, let's make this one the green one, yeah? We'll look for slope. So A is going to rise from here to here. It's going to rise -1, 2, 3, 4, 5, 6. So this goes down 6, and it goes 1, 2, 3, 4 over 4. So the slope of A, this A is not anything mathematical. It's just a name. The slope of A is rise over run. If you simplify that, that ends up as what? 3 halves. Yeah? Do the same thing for B. We'll do it in blue, right? Same. So the slope for B is rise 1, 2, 3, -3. It's going downhill over run 1, 2, right? So -3 over 2. What do you notice about this slope and this slope of the parallel lines? Wow, yeah, they're equal. So you should write that in your notes. Parallel lines have equal slope, equivalent slope. All right. These are perpendicular lines. Perpendicular lines cross at a perfect 90-degree angle. That's what this little box means. 90 degrees, and this is 90 degrees, and that's 90 degrees. All these are 90 degrees. What I'd like you to do is take this point and another point that hits nicely. I think this point. So find the slope of C. And then also go from I'm trying to find a nice spot where it actually hits perfectly on the grid. I think this point and this point, and find the slope of D. You can use any point, but these are the ones that I think actually hit the target. Cool? Try those, find the slopes for those two, simplify them, and then tell me what you see and how perpendicular lines, how do their slopes relate to each other. Go. All right, here's mine. I'm going to start from here to here, and so this goes 1, 2, 3, 4, 5, 6, 7, 8. And it's going downhill, so that's -8 over runs 1, 2, 3, 4, 5, 6 over 6. Simplified to -4/3. Great, there's our slope. We're going to do the same thing with D. It rises 1, 2, 3, 4, 5, 6. So this is up 6. And it runs 1, 2, 3, 4, 5, 6, 7, 8. Right? 6 and 8. Which simplifies to 3/4, but it's positive. The two things that I want you to notice is the fraction is the same, but flipped over. Yeah? That's called reciprocal. Reciprocal. Sorry, it's slow. I'm drawing with the mouse. That's called reciprocal. The reciprocal of 2/3 is 3 halves. It's not equal. They're reciprocals, right? They're just flipped over. So, yeah, perpendicular lines have reciprocal slope. They also have opposite signs. Yeah, one's going to be positive, one's going to be negative, right? So if this was the slope of one line, the other one would have to be negative. If this one started negative, this one would have to be positive. So they're different signs, there's flopped signs and flipped over. So, and we call that opposite reciprocal slope. Opposite reciprocal slope. You'll hear that a lot. Opposite just means plus or minus difference, and the reciprocal slope means if it was x over y, it'll be y over x. Right? It's the flip-flop. Cool. So perpendicular lines have opposite reciprocal slope. Put that in your notes. Great. So trial by fire, you try to find the slope for this. Pause me, make sure you're confident. Go. All right, let's go green. So slope for this is going to be rise over run. change in the vertical over the change in the horizontal. So it rises 1, 2, 1, 2 units. So it goes down 2 units. Yeah. And it goes over 1, 2, 3, 4 units. Cleans up, simplifies to -1/2. And there's your slope. Cool? That's what we're going to check out tomorrow. Come ready for a little quiz and some practice. We'll give you some practice problems. Cool? Bye.